It's expected in this GCSE syllabus that you know what the value of sine 45 is, and it's 1 over root 2. You can obtain it from, yeah, why not, from drawing a right-angled triangle with bases 1 and 1. Use Pythagoras, so this is isosceles, so this will be 45. And then you can use Pythagoras' theorem, 1 squared plus 1 squared, square rooted, is the square root of 2. And then you can quickly see that sine 45 is the opposite divided by the hypotenuse. It's 1 over root 2. Not necessarily, I mean, it's useful to be able to kind of generate this from here. So you can also get the cos 45 as 1 over root 2, and you get the tan 45 as 1, in fact. And there's other ways of dealing with 30 and 60. There's also ways of helping you to memorize it, which I'm not going to go into here, but that's the answer, 1 over root 2. You actually then don't use that, so it's just a 1 marker testing your knowledge of that. Now we've got two right angled triangles, and it tells us some lengths, and it tells us that tan 30 is 1 over root 2, and we want to find out this length here. At the moment we've got none of the lengths and none of the angles, so that's not very useful, but let's do something with this triangle. If I can work out, because I've got this angle and this length, I think I can work out BD. It's going to draw a little outline. Okay, so now I'm going to label my triangle and use trigonometry. So this is the hypotenuse, this is the opposite, and this is the adjacent. I've got the adjacent, I want the hypotenuse, I've got the angle. I can use tan, which funnily enough they've given me the formula for tan 30. So I can write down that tan, let's write it down, tan 30, sorry, tan theta is O over A, that's the general formula. In this case, tan 30 is going to be the opposite, I'll call it capital O still, divided by 10 root 6. Okay, and we know that tan 30 is 1 root 3, so I can write 1 root 3, and then I can multiply it by this 10 root 6, oof, equals O. It's not 0, it's O, opposite. Okay, this is looking not particularly nice, but we can actually tidy it up. We can say that O is equal to 10 root 6, which I can write as root 2 root 3, and then I can divide it by root 3, and overall O is 10 root 2. That's a more simplified form of it. Okay, there's one other thing they told me, I've just realized that I've not used yet. BC is equal to CD. These are the same length. Now, how does that help me? It helps me because it's isosceles, it's an isosceles right angle triangle. So actually this is 45 and this is 45. So I could in theory use trigonometry again to work out what BC is if I knew what sine 45 was, which I do. So I'm going to go with that actually. I can write down using SOHCAHTOA. So sine. So I can write down that sine. So this time, right? If we look at, let's I want to know this one. Right, let's ignore this angle. Okay, let's deal with this one. Then this is the opposite now. This becomes the hypotenuse, and this is the adjacent. We're going to use sine. We can write down that sine 45 is BC, which is what I want to find, divided by 10 root 2. But sine 45 from part 1 is 1 over root 2. So it's going to be that BC is equal to 1 over root 2 times 10 root 2, and we're there because these cancel and BC is equal to 10. Now, how do you do this question if you can't do part A and you don't know what sine 45 is? Well, there is another way. So we're going to talk about that just quickly. It's a really nice way because it's a right angle triangle. Okay, you could use Pythagoras' theorem. So you could say that because these two are the same, then they're both BC, and it must be that BC squared plus BC squared, because CD is the same thing, will equal this 10 root 2 squared. Okay, I've used Pythagoras' theorem on this triangle, I'm working in terms of BC for both of these shorter sides, and I'm saying it's equal to this 10 root 2 from before when we square them. So that's going to mean that 2BC squared is equal to 100 times 2, because I'm put an extra step in. 10 squared times root 2 squared. And that is 100 times 2, or 200, and therefore BC squared is going to equal 100. I can square root it, and I can also get 10 that way, I think. I don't know which way I prefer, to be honest. I think I just about prefer the Pythagoras way, because you don't have to recall this this angle. So it's a bit, but there's a bit more involved in terms of square rooting and so on.